Experimental and theoretical probability. What possible outcomes do you see in each object? Here there are 4 outcomes: red, yellow, blue, and green. Here there's 2 outcomes, heads or tails. On a die there are 6 outcomes, 1, 2, 3, 4, 5, and 6. Experimental probability is the likelihood of an event occurring based on the actual results of an experiment or trial. So the experimental probability of an event is approximately equal to the number of times the outcome happened divided by the number of times the experiment was repeated. Let's try an example. Determine the experimental probability of heads from all possible outcomes if a coin is flipped 5 times. First, list all possible outcomes. If we flip a coin 5 times, there is a chance that it will land on tails 5 times. There's another chance that we'll get 4 tails, 1 heads, a third chance that we get 3 tails, 2 heads, and so on. So now we can determine the experimental probability of heads from all possible outcomes if a coin is flipped 5 times. So, in the first case, remember we got 5 tails, 0 heads? There were 0 heads, which means that the experimental probability in that trial of getting heads was 0% chance. While in the final case, if you get all heads, then the probability would be 5 out of 5, 100% chance of getting heads. All of the possible experimental probabilities are shown in the table to the right. Notice how the experimental probability depends on what happens in each trial. Before we run an experiment, we do not know which outcome will result. But as I said before, the more trials you get, the closer you're going to get to a 50-50 chance of getting heads. Example 1. Golf. A golf course offers a free game to golfers who make a hole-in-one on the last hole. Last week, 24 out of 124 golfers achieved this. Find the experimental probability that a golfer makes a hole-in-one on the last hole. The probability of a hole-in-one, the experimental probability, is the number of successes divided by the number of trials. Out of 124 golfers, 24 got the hole-in-one. This can be reduced to 6 over 31, or a 19% chance. Out of 31 golfers, you can expect 6 to make a hole-in-one on the last hole, based on these trials. You can also say there's a 19% chance of a golfer making a hole-in-one on the last hole. Example 2. Surveys. Of the first 40 visitors through the turnstiles at an amusement park, 8 visitors agreed to participate in a survey being conducted by park employees. Find the experimental probability that an amusement park visitor will participate in the survey. Of the 40 trials, 8 were successes, so the probability of participation is 1/5, or 20% chance. There's a 20% chance of a visitor participating in the survey based on this experiment. Theoretical probability is the likelihood of an event occurring based on all possible outcomes, assuming that all outcomes are equally likely. So the probability of an event is approximately equal to the number of favorable outcomes divided by the total number of possible outcomes. What is the theoretical probability of spinning green? Is this a fair probability? The answer is 1/4. There is a 25% chance of spinning green. This is a fair probability, since a probability is fair when there's an equal probability for each outcome. That is true here because the areas for each outcome are the same, so they're all equally likely. Find the theoretical probability of randomly choosing a white marble from the marbles shown. Alright, so since there are 4 white marbles, there are 4 possible favorable outcomes, right? Picking any of these 4 would be a success, favorable outcome, so there's 4 of them. Out of a total possible number of outcomes of 10, because there's 10 different marbles. So this reduces to 2 over 5. There's a 2 in 5 chance of picking a white marble, or a 40% possibility. Suppose you randomly choose a gray marble. Find the probability of this event. Of the 10 possible marbles, 1, 2, 3 of them are gray. Therefore, 3 out of 10, there's a 3 in 10 chance of picking a gray marble, also known as a 30% possibility. Suppose you randomly choose a marble that is not gray. Find the probability of this event. So that would be either a white or a black marble. Not gray is now the favorable outcome. So of the 10 marbles, 7 of them are not gray, right? 4 of them are white, 3 of them are black. The 7 of these are all not gray. Therefore, there are 7 favorable outcomes out of a possible 10 outcomes. Therefore, there is a 70% chance of picking a marble that is not gray. Since probability works on a scale of 0 to 1, there's another way we can approach this problem. If the probability of picking a gray marble is 3 out of 10, we could subtract that from 1 to find the probability of picking a not gray marble, right? When you pick a marble, it's either gray or it's not, which means there's a 100% chance that you're going to pick a marble. There's a 3 out of 10 chance it will be gray, and the 1 minus that gives you the chance of it not being gray, 7 out of 10. But when you pick a marble, there is a marble. It's either gray or not gray. Those two odds, 3 out of 10 and 7 out of 10, they have to add up to 1. This example allows us to draw a general conclusion for the probability of events not occurring. Since the probability of not event occurring is the number of unfavorable outcomes over the possible number of outcomes, finding 1 minus p event will always equal the probability of the event not occurring. So the probability of A not occurring equals 1 minus the probability of A occurring. Find the probability of getting tails when you flip a coin. There's a 1 in 2 chance of getting tails when you flip a coin because there's 2 sides to a coin, heads or tails, and tails is just one of those 2 options. So that's a 50% possibility. Each student in a classroom of 12 students flips a coin 10 times and records the number of heads and the number of tails outcomes. Each student calculates the experimental probability of flipping a tail and flipping a head. Use the experimental probabilities determined by each student to calculate the entire class's experimental probability for flipping a head and flipping a tail. If you look just at student 6, you might think there's a 100% chance of always getting a heads, 0% chance of a tails. But that's an anomaly. If you actually average them all out, so 12 students flipping a coin 10 times is 120 coin flips. And so if you sum up all of the heads of those 120, you get 62 that landed on heads. That's 52%. If you sum up all the tails, 58, and put that over 120, the total number of flips, you get 48%. And what's cool is that the more trials you do, this will get closer to 50%, this will get closer to 50%, right? This will decrease a little bit, this will increase a little bit with the amount of trials. Here's a class activity. Determine the theoretical probability for flipping a coin and getting heads. Flip a coin 10 times and compute the experimental probability for getting heads. Compare the experimental probability you found to the theoretical probability. If possible, combine your results with others to determine the experimental probability based on your combined results.